Okay, so we're back with our presentation. So I hope you have learned about some of the important expected lessons that we'll be talking about in my first presentation a while back. Okay, so let's continue presenting the important terminologies or the important concepts that we'll be discussing as we go on in this subject, statistics in research. So we have already talked about the methods in presenting the data, which are the textual, tabular, and the graphical presentations. Now take note that when deciding what method you will be using in the presentation of your data depends on the nature of what you are presenting, nature of the data that you are presenting. Okay, so let's consider deeper the tabular presentation, because this is what we often use when we are conducting research studies. We often present our data through tables, statistical tables. Okay, so in statistical tables, we can present a frequency distribution table. When we say frequency distribution tables, this is a group data. Okay, so this is a group data. So when we say group data, it is an interval presentation. So the data is categorized in several groups or several intervals. Then based from these groups or based from these intervals, we now present the frequencies. These frequencies represents our sample. Okay, these frequencies represents our population. Then we also have, or we can also have, the cumulative frequency distribution table. So when you say cumulative frequency, this is a part of the frequency distribution table which we are presenting the less than or greater than cumulative frequencies. And the possible graph, take note that the possible graph of the cumulative frequency distribution, or if you are doing, or if you are presenting less than cumulative frequency, then that will be a less than OGI. Okay, so take note that the graph is called OGI. O-G-I-V-E. OGI. Okay? Now, however, if you are presenting greater than cumulative frequency, then we can present it through graphs, calling it as greater than OGI. Okay? Now, next is we can also present the frequencies into its relative frequency distribution table. So it's a relative is relation of those frequencies to the total number of n or frequency. Total number of populations, should I say. Say for example, in the first interval, there are 7 frequencies. And the total number of populations that we have conducted, that we have gathered, is, let's say, 100. So the relative frequency of the first interval having 7 frequency is 7 divided by 100. So if you divide it, that will be 7 divided by 100. That is 70% or 7%, right? So 7% was or belongs to the first interval. So that will be an example. Okay, next. We will also describe or discuss about the several statistical tools under the descriptive statistics. So when we say descriptive, as I said a while back, it's we try to describe our data. We can describe it using the average, using the standard deviation or the variability of the data. We can also describe it how peak the data is, how normal the data is. Okay, so in that way, we are doing descriptive statistics. Okay, so the first descriptive statistics that we will talk about is the central tendency. So when we say central tendency, we are looking for the center of our distribution. Okay, so how do we look the center of our distribution? How do we look the centrality of our distribution? We can look at using the mean, using the median, and the mode. Okay. Of course, when our data is in interval in nature or in quantitative in nature, the most appropriate tool to use is the median. What about if the data is in nominal in nature? Can we still use the median or the mode or the mean? Sorry, no more. So what we do is we will be using the mode because mode is good for phenomenal data. Okay, so these are the three important measures of central tendency. We have the mean, of the median, and we have the mode. Okay, next, measures of variability. When you say variability, it is the average distance of this set of data with respect or around the mean. Okay, what are the distances of this data around this mean? We have already computed the mean, we have already computed the center of our distribution. These are now the data. Okay, what is then the distances of this data to this mean? From this data to the mean, from this data to the mean, from this data to the mean, and so on. So if we are looking for the average data, average distances of the data around the mean, we are talking about variability. And that is the definition of standard deviation. Okay? Now, we have other measures of variability that we can use. The difference between the lowest and the highest is all about the distance from the lowest to highest, and that is what we call the range. The mean absolute deviation, and we can also have the variance. Okay? The next is the measures of position. This is another descriptive statistic that we can present, that we can use in the analysis in our research study. So when we say measures of position, these are quartiles, decile, and percentile. Okay? So, of course, we will be computing for the measures of positions depending on the data. The nature of the data, whether it is a group data or a non-group data. So if the data is ungrouped, we can use the Mendenhall and Sinch method. Okay? So when we say Mendenhall and Sinch method, this is one way of computing for the quartile, decile, and percentile. And another method when we are computing for the positions of the data in ungrouped data, sorry, we can also use the linear interpolation. Okay? But in a group data, it is very easy to compute because we have a formula that has been devised, that was devised, that is good for the group data. Okay? The measures of skewness, another descriptive statistic that we will be talking. So whether it is a normal distribution, when we say normal distribution, it is a bell-shaped curve. Okay? The SD1, and so on. It's skewed to the left. When we say skewed to the left, the tail is on the left, and the bulk of the distribution is on the right. Okay. We also have skewed to the right. When we say skewed to the left or to the right, the tail is on the right, and the bulk of the distribution is on the left. Okay. So another one is the measure of cortosis. Measure of cortosis tells about how thick or how flat the distribution is. Is it more thick than the normal? So if that is more thick than the normal, then we can say the cortosis of your distribution is left to quartic. If that is flatter than the normal distribution, then that will be a flat to quartic. Now if the distribution is normal, automatically that will be a mesoquartic. Okay? So take note that in the skewness and cortosis, to be able to define it, whether it is normal distribution, skewed to the left, skewed to the right, mesoquartic, flat-quartic, or leptoquartic, we need to consider an index. Okay? We need to compute for the value of the skewness of the data. We need to compute for the value of the cortosis of the data. Okay? And the last descriptive statistic that we can use is the measures of correlation. And there are several statistical tools, take note, that we can be used in correlating, whether it is a bivariate or multivariate correlation. Okay? Now take note that descriptive statistics, these descriptive statistics are also used in the inferential statistics. Without this descriptive, we cannot infer. Okay, take note of it. We cannot infer without the help of the descriptive values. Okay, descriptive statistical values. Can you follow? Okay. So we will further talk about this correlation later on. Now, when we are now in the differential statistics, the first thing to do, or that we'll be talking about, is the testing of hypothesis. Because we have now a claim, we try to prove that our claim is true or not. What we can do is to do the inferential statistic. So we will try to talk about kinds of hypothesis. In research, there are two major types of hypothesis. We have the alternative hypothesis and we have the null hypothesis. Okay, we often denote or use the symbol for alternative as HA, while for the null hypothesis we often use the HO. Okay, HO hypothesis. Then the proper way of stating the hypothesis is also needed in our discussion. Two types of hypothesis testing. Okay, there are two types of hypothesis testing, whether it is a one-tailed test or a two-tailed test. Okay, is it when we say one-tail, it is directional. When we say two-tail, it is non-directional. Okay, then the steps of hypothesis testing. Okay, we will also talk about the inferences about the population mean. Okay, and these are the four major steps when we are inferring population mean. First is to make assumption. The next is to state the null hypothesis. Then select sampling distribution and establish critical region. What is your critical region? Is it at 0.05, 0.01, and so on? Okay, then compute test statistics. Inferences about difference between two means for independent samples. Say for example, you want to know the difference between the performance of the two independent groups of students in a school. So in that case, we'll be using t-test for independent sample. Now say for example, we want to know the difference between the pre-test and post-test scores of the students. Take note, we have the same group of students, but they took the exam twice. Before the instruction, after the instruction. So in that case, to be able to differentiate the two, we will be using t-test for dependent sample. Okay? So, and lastly, we will talk about inferences about correlation and inferences about differences. Okay? So this is now the end of my presentation about the expected lessons or expected topics that we'll be talking about in this subject, statistics in research. Next meeting, we'll be having a formal discussion about the lesson starting on the basic terminologies and the two major branches of statistics. Thank you for listening and have a good day.